do. All right, here we are. We are back. We are back. All right. Hi, everyone. I hope everybody's doing okay. Try and get that going there. There we go. That probably will work. Something to that effect. Yeah. Hmm. All right. All right. How's everybody doing today? Hopefully everybody's doing okay. Hey, hey, Adam. How you? How are you doing? Yeah, this is my final class for at least Tuesday. I teach 4 days a week, Adam. So I have classes on Tuesdays and Thursdays at 9:30 and 11 o'clock, and here at 4 o'clock. And then I have some classes on Mondays and Wednesdays at 1 o'clock and 5 o'clock, respectively. So I have a schedule up there on my channel. I might be adding to that fairly soon. So yeah, you definitely come check me out. I'm here 4 days a week, Monday to Thursday. So you betcha. Right on, man. If you want to sit and chill and just shoot the breeze, it's all good with me. Got no problem with that at all. As long as you enjoy yourself, that's all that matters at the end of the day. All right. I'm going to get ready in about a minute or two. Let a few more people come on in. And we'll go get started. Gerda, hello. How are you? I hope you are doing good. How was your weekend? Pretty good? Excellent. That's very good to hear. Excellent, excellent. Hopefully you're ready to. Do I think that math is hard? Yes, I do. I think math can definitely be hard. I think a subject that is basically its own language can be very difficult to interpret. But does it have to be hard all the time? No, it doesn't have to be hard all the time. Uh, Math can be a subject where, you can enjoy. At the same time, I thought math was hard for a long time too. So, I mean, you struggle and, I'm not expecting perfection. I'm not expecting, oh, you got to get everything. Like, that's unrealistic. But can you use it for something practical? Sure. I think a lot of things in math you can definitely be practical about. Hey, yeah, somebody who tells you something is easy, it's like saying, "Oh yeah, shoot a basketball, into a hoop." It's like, you know, you could do that, but it's not easy. I mean, look, everybody's watches like the NBA and stuff, but you know, it's not easy to shoot a basketball through a hoop. You got to have the right rhythm and the right power and the right, there's a lot of things that go into it. How many classes do I teach, Chase? I teach, currently I'm teaching 6 classes. Yes, six. 6 classes. Although I have 7 classes for the semester, but six is what I'm currently doing. So I'll be swapping out one class with another come the 8 weeks. So that's at least what's on the agenda there. Yeah, typically I do like 5 to 6 classes a semester. Yes, exactly. Here's a good way of putting it, Gerda. Like, because that's the best way to put it there. A good way of putting it is like if you do a job, right? If you do a job, and let's say at first when you go to a job, you don't know what you're doing. That's why you need the training and stuff. Um, but then the more and more you do it, the easier and easier that task becomes. So at first, it's really, really hard. And she's like, I got to learn new systems. I got to learn how to do this, that, the other thing by company protocol. I got to follow this rule, that rule, and the other rule. And then, fast forward 6 months, a year later, and it's just like everyday work now. Now it's just like, that was pretty easy. I know what I'm doing. I may be the pro. Yeah. I mean, thank you. I appreciate that. I could have a max of as many hours. It depends on hours, Chase. I work 3 classes at each college, so for this semester anyway. I may be a pro, but it doesn't mean that I shouldn't be unaware about people who have, difficulty with the subject that I would consider still difficult even to this day. I have to definitely be aware about that fact. For me to proclaim everything is easy and everything, I could walk into a room and be like, bam, look, I understand all the math all the time. Oh my God. You know, uh, yeah, that's just not realistic either. Trust me, I feel I have felt the struggle bus before. For me to claim that I got A's in all my classes would be ridiculous. I failed math classes before. It's not anything new to me. I've done it before. I've failed other classes too, you know. So yeah, look, if for me to come out here and say, yeah, I was the prodigy, man. Okay, I had the ungodly talent of numbers. Like, nah, heck no, of course not. I had to claw my way back up. You know what? Even to this day, Gerda, I still consider myself a noob. I'm still a noob in a lot of ways. I think you have to keep yourself grounded because if you think that you're better than other people, then guess what? There's always going to be somebody who's going to basically show you up. There's going to be somebody who always will be better. I just prefer to be myself instead of comparing myself to others. That way I can do my part and then, be able to pass that on to all of you. That's a lot more productive than just putting my ego and just saying, you know what, I'm so much better than you, and blah, 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 blah. Yeah, exactly. I understand everything, and you're gonna never get to my level because I got big cojones and blah blah blah. Like, what does that prove? It proves absolutely nothing. It proves like it's a waste of time, a waste of energy, and it's just so discouraging at the end of the day. I'm like to say, here's some information. Use it the way you will. I understand some of this information will not be relevant to you, and it's just like, here you go. You do use it if you need to. May not use it if you don't, but here's some application for it, or here's something that you can learn. And if you happen to use it someday, great. If not, okay. That's fine. That's what a facilitator of information is supposed to do. They give you the option about where you can use it or not, but that's it. It's as simple as that. I don't know why it has to be so complicated. You have a teacher that teaches programming, he's just like that. Yeah, because he thinks he's better than hot shit. Yeah. So I don't think anybody's better than anything. There's always like another person who's always better than you. And for that person who thinks that he or she is at the top of the pile, you know what? That person usually will be thrown off that top of that pile and replaced by somebody else anyway. Are we starting on question 8? Yes, we are, Sir Chase. Absolutely. We are starting on question 8 here today. I guess if I have to add one more thing, that's why I consider everybody here an equal as opposed to a teacher student relationship, because it's a lot easier to talk on the level than it is for me to lord over you and say, you suck. So it requires more effort and more time, and I'm too lazy for that shit, and I don't need it in my life, and neither does anybody else in this chat. So it's okay, my friend. You do things your way, okay, Chase? That's just how you roll, bro. Nothing to hate about that. All right, we better get started here. All right. Okay, let's get started today. Welcome back to Tuesday. Hopefully, you have a nice weekend. So, today we're going to be continuing where we left off from last time. Last time we talked about how to graph rational functions. We spent a fair amount of time just kind of getting all the information out from rational functions, and the intercepts and the asymptotes, and then kind of putting that graph together. We had a good time doing that, so that turned out pretty well. All right, so today what we're going to be doing here is we're going to get on here to the next section, section 3.6. We're going to be talking about inequalities here in section 3.6, and we'll probably have time here, though I'm not sure, just depends on how fast the examples go. We'll get to section 3.7, the last section here, which is talking about variation. So we'll discuss that should we have time. I kind of expect it, but still, just in case, just to give you a little bit of preview. In any case, let's talk about polynomial inequalities and rational inequalities. All right, so let's go ahead and look at question 8 from the last handout here. All right, so question 8 says, what are polynomial and rational inequalities? Okay, so as you can see here in the question, we have two types of questions. We have a polynomial and a rational inequality. So let's first talk about a polynomial case. And we'll write down a polynomial case right here. So here's a polynomial inequality, and this is just an example. Okay, so we'll do this example here in just a second, a little bit, sorry, but just to kind of point out what it would look like here, just as a simple example. Afternoon toast. I hope you're doing well. All right, so here's a polynomial inequality. It looks just like this, like 3x squared plus, oh, that should be 10x there, my fault. Uh, 3x squared plus 10x minus 8, okay, is less than or equal to 0. So there is a pure example of a polynomial inequality. Again, it could be a quadratic. It could be, again, any polynomial. It could be a degree 3 polynomial. It could be a monomial, okay? You know, x plus 1 is bigger than 5, whatever. All right, so it could literally be anything. And we're going to be able to want to solve for x here that satisfies, say, this inequality that we see up here. Now, as for rational inequalities, let's look at that here. So rational inequality is exactly as it was last week when we looked at a rational function. So let's go ahead and at least write down a rational inequality and what one would, particularly look like here. So this is 2, I guess. Sure. So let's say x plus 5 over x plus minus 2 is bigger than 0. I'm doing very well, Toast. Very well, my friend. So this is an example of a rational inequality, and we're going to see how to actually determine the values for x that satisfy in each one of these cases. Okay, so it's not too bad, but it does require a little bit of organization. That's going to be the real key here. So let's go ahead and put that down at least. I think that's worthy of some mention here. So the key here is going to be organization. If I can spell it, maybe. All right. I cannot spell organization. I'm pretty bad at spelling. So, and I wonder how I taught English for 4 years. All right. Anyway. All right. So we're going to be able to organize our answers here to kind of get to our final result. So let's go ahead and talk about the first question here, right below it. How do we solve for polynomial inequalities? All right. So as you can see here, let's take this example that we see right here. Okay, 3x squared plus 10x minus 8. We're going to go ahead and do that example, and we're going to see exactly how we can solve for x in that instance. All right, so I'm going to bust out the paint tool for this one because it'll be actually significantly easier for me to do so. So we have 3x squared plus 10x minus 8 is less than or equal to 0. All right. Okay, so what I'm going to do is I'm going to kind of go back and forth a little bit. I'm going to describe the steps here. We're going to do the steps on here on the canvas here, and then I'll kind of shuffle back and forth between that and Word. Okay, so let's talk about step number 1 here. Okay. Okay, step 1. The first thing that you want to do is when you want to solve for a polynomial inequality, make sure that you have moved everything over to one side of the inequality. That's actually the first step. So we want to be sure that we have bigger than or equal to 0, or less than or equal to 0, or bigger than 0 or less than 0. That's what we want. That's what we're going to aim for. Okay? So that's step 1. Now we already have that here in this particular instance, mind you. That's perfectly fine of what we have on this guy here. So that's shouldn't be too much of a problem. Where'd it go? Did I just have this? Oh, it was on a separate one. Oh, that would be a problem. All right. So we already have this. This is less than or equal to 0. Okay, so that's exactly what we're after for step 1. Now let's talk about step number 2. And now things will start to change, of course. So step 2. Step 2 here is to factor the polynomial. So we want to factor the polynomial here. So that's what we're going to do here for this question. Let's go ahead and factor this polynomial. Now for us to do that, we're going to use, in this case, the AC method in order to factor this polynomial. All right, so let's go ahead and do that right now. So we're going to have, if you recall here, I do A times C, so I do 3 times -8. So that's minus 24. We'll find two numbers that multiply to minus 24 and also add up to 10. Okay, so let's see. What do you think? Two numbers that multiply to 24 and add up to 10. What two numbers would satisfy that? Six and four? 6 and 4 would not equal minus 24, unfortunately. I would agree 6 plus 4 is 10, that's true, but 6 times 4 would be positive 24. 12 and minus 2, that's correct. Oh, yeah, my bad then. No, that's on me then, if you didn't see the negative. All right, so what we did next here is we took the 3x squared, and then we split up this 10x in terms of the two numbers that we found here. So this will give you a gentle reminder about what we did, quite a while back. So 12x minus 2x minus 8. Okay. And now we're going to go ahead and factor by grouping here. So we get 3x and we get x plus 4. Bring that minus sign down. We're going to factor out a 2. And we get x plus 4 again. Switching the signs around. So this factors to 3x minus 2x plus 4. Okay. So that's our factoring that we got here in this instance. So that here is step number 2. Okay, that's all of step 2. We'll get to do more of this in just a second, but just pointing out how we got that. Okay. Step 3. Find the zeros of the factored polynomial. Okay, so we want to find the zeros of the factored polynomial. Well, this part is not hard because, well, we did all the hard work right off the bat. So we just are going to find these two zeros here. So we set, again, for step 3, we set 3x minus 2 is equal to 0, and we have x plus 4 is equal to 0. So this is pretty easy here. Shouldn't be too hard. X is equal to 2/3, and x equals minus 4. Okay, so no problem. There you go. We got two zeros there based on what we see. Fair enough. Okay, now comes the most important point here. Okay, so now the next few steps here are going to be pretty much repeated for rationals to some degree. We're going to go ahead and take a look on how we can met this out. And this is why I want to do it on the paint tool, because it's actually significantly easier. So let's go back to our Word document. All right, now let's talk about step number 4 here. So step number 4 is going to be this. You're going to chop up the number line using the zeros in step 3. Okay, so you're going to chop up the number line using the zeros in step 3. Then determine the determine the intervals that are possible after doing so. Okay, let's talk about what happens here. Okay, so we're going slow over this, so I just want to talk about what this means. Okay, so it says, let's go back again. and it says chop up the number line using the zeros found in step 3. Okay, I should say found in step 3. Don't know why I missed that. Then determine the intervals that are possible after doing so. So the reason why I do this step in particular is because I want you to visually see what possible intervals could be our answers to this problem. So how does chopping up the number line go? How does this go? Well, let's take a look here at our 2 zeros, at least in this case 2 zeros. So we have our number line here. All right, and with the number line, we start at minus infinity, and we go all the way up to positive infinity. Now we have two numbers here. We have x is equal to minus 4 and x is equal to 2/3. So we're going to put minus 4 here, and we'll put 2/3 over here. So negative 4 and positive 2/3. Now, the other question people ask is like, okay, well, what kind of intervals are we going to get? Remember, with interval notation, we have brackets and parentheses. Okay, so this is where the important part of the original inequality is going to come into play. Notice that this original inequality is less than or equal to 0. All right, so in this case here, and I'm going to add a note. All right, so let's do that. So in this case here, we're going to have, say, if we have less than or equal to, or bigger than or equal to 0, then we're going to use brackets. Okay. If it's strictly less than or strictly bigger than, use parentheses. Okay. So I'll put that as a note here. Note. If using if you have less than or equal to, actually, let me do it that way. That way is actually better. If you have less than or equal to, or bigger than or equal to, where is that guy? Oh, try and find that guy. I know it's around here. I've just totally lost it. Oh, here it is. Okay. Yeah, for some reason, I was like, oh, where'd it go? All right. All right, so if you have bigger than, less than or equal to, or bigger than or equal to, doesn't matter. All right. We're going to use the brackets. Okay. So use the left bracket or the right bracket. Okay. If you have less than or bigger than, then you're going to use parentheses. So left paren or right paren. Okay. All right. All right. There we go. Okay, so let me show you what this means. Okay, so it's like, well, that's a lot of writing for that, but let's show what this means here. So because this is less than or equal to, I'm going to put a, now next to parentheses, always go here. And then we put a bracket right here at minus 4 because this is less than or equal to. I'm going to put a bracket here on minus 4, put another bracket here at 2/3, another bracket here, and a parenthesis right here. Okay? Okay, so the three intervals that we found that are our possible answers are going to be negative infinity to minus 4, okay, negative 4 to 2/3, and finally 2/3 to infinity. So these are our three intervals that we have found here for this particular problem. So this is step number 4 right here. Before we move forward, are there any questions about that? Nope. Okay. Okay. So, what's the point of that? Isn't that every possible number? Yes, it is every possible number within a particular frame. So you have to understand here, we're actually going to test out, in this case, different intervals to determine what would satisfy the original inequality. So we are taking every possibility, but we know exactly where to kind of chop off because of the graph behavior. Now, I want to add to that answer there. Um, what about the junior? Like the Whopper Junior? I don't know. Wait, JR? Oh, the U. Oh, I thought it said the junior. I'm like, wait, what happened? Yeah. So what about the U there? Yeah, let's talk. We're going to talk about that in just a second because the next step will now make a whole lot of sense once we put this together. So we have 3 intervals, as you can see there. All right, but there's more to it than just those intervals. These intervals are not necessarily the answers. It's like if we narrow down our answers to 3 intervals. Okay, so we're not quite done just yet. Yeah, the union there. That's correct. So let's go to step 5 so I can clarify this for all of you, because at this point you're like, well, what am I doing with any of this stuff? Okay, that makes perfect sense. All right, so what we're going to do is we're going to organize a chart that contains each interval and take a test point from each interval and determine the sign of the test point in the original function. Let's go to step 6 here. Step 6. Your answer will be the one that satisfies the inequality with 0. Okay, so let's talk about these last 2 steps. You're like, whoa, 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 time out. What do you mean by that? Okay, what's going on here? Okay, and that's a very fair question. So we want to organize a chart that contains each interval. We're going to take a test point from each interval, and we want to determine the sign of that, a sign of the value, uh, the sign of the test point at in the original function. So we're going to actually put the test point in the function, all right? And we're going to find out what that value is going to be. So let's take a look. We don't care about the actual value here, so I'll show you what I mean here right now. Okay, let's make this canvas super big now. Okay, so I need more space for this. All right. So what I'm going to have over here on the right hand side is I'm going to go ahead and make up a little chart here. Okay, so I have the interval here. All right, I'm going to have my test point. I'll add something to that here, and we're just going to put plus or minus. Okay, for our last little column here. Now we do have our 3 intervals. Okay. So we have this, we have -4 to 2/3, and then finally we have 2/3 to infinity. Okay, now The one note I am going to make in regards to this is the most common mistake I see for most people. So let's make that side note there because let's avoid that mistake here. So note, your test point must be in the interval. Okay? So you have to be very careful and choosy about how you pick your test point. You have to make sure that you just can't be all willy-nilly and say, I'm going to throw out that number there. No, that test point has to be within the interval. All right, so whatever the interval is that you found from the previous step, now you're going to go ahead and find that. You're going to go ahead and use a number within that interval. So in this example here, if you take a look, we have negative infinity to negative 4. I want to pick a test point that's between minus infinity and minus 4. So what's a good test point to choose? What's a number between negative infinity? Negative 6? All right, that's fair. Negative 6, that's fine. No problem. Let's pick the next one here, negative 4 to 2/3. Let's pick a number between there. What's a easy number to choose? I want to pick a number here between minus 4 and 2/3. So I don't want to pick exactly minus 4 because that gets me 0. So what's an easy number between minus 4 and 2/3? Minus 2, okay, that's fine. Yeah, so let's add a little bit to that because I think that'll clear up any confusion. So do not choose any zeros, okay? Any zeros you get, do not choose those as your test points. Yeah, 0 would just be just as good, Chase, absolutely. 2/3 to infinity. Let's pick an easy number that we can work with. 1, okay, that's fair. Okay, so these are our 3 test points, and that's perfectly fine, okay? Now, all we want to do next is to go ahead and figure out what the value of the function is at each one of these test points, okay? So we're going to go ahead, and in this case here, again, we're going to go ahead and plug in minus 6 into our original function that we had all the way at the beginning. So again, all the way at the beginning here, because we got the 0 part. So once we got the 0 part, we're going to plug it into that function there. Now, the easiest way to do that, of course, you can write it out, or you could just put it in your calculator there. That'll make it easy. So if you want to put that in your calculator, just hit the y equals key, put your function in there, 3x squared plus 10x minus 8. Then you can go to your table. So hit second in graph to go to your table. And probably from last time, you still have it on ask, so you can plug in minus 6, and it will pop out an answer here for minus 6. And does anybody got an answer here for minus 6? If we plug in minus 6, what do we get for our value? Okay, so the correct answer, that's correct, Morning. The correct answer here would be, so you should have gotten 40. So Right. So let's talk about that. Okay. Now, in this case here, we don't actually care about the 40. All right. What we want to look at here specifically is we want to specifically look at if it is positive or negative. That's the only thing we care about, if it's positive or negative. So 40 is just a way we could see, oh, it's positive 40. Okay, so positive is the only thing we care about. So we're going to put positive here in this case. You mean the value that is the same in all y values. I'm a little confused by that question, Planet. What do you mean by that? I just want you to clarify so I can clear that up. So all we did for this, just to let you know, is just plug in -6 in for x in f of x. That's all we did there. If you meant all the x values there, then yeah. If that's what you meant there, Planet. Yeah, so you should get one y value for 40. So if you plug in -6, you should get 40. That's it. So right, okay, I understand now. So if you plug in x is equal to -6, you should get a y value of 40. Yes, the sign of the number is what we should be looking at. So 40 is just a way we could just confirm, yeah, it's a positive value, okay? That's what we want to be looking at there. That's right. Now we can repeat this process again with our other two values. So let's try -2. And if you see there, okay, cool. So if you see there, we got -2. Do we get a positive or negative number there at -2? So at -2, do we get plus or minus here? All right, good. That's correct. So we're going to get a negative number here, and that's fine. Sounds good to me. All right, let's do the last one here. Let's do 1. So if we plug in 1 in there, what do we get for our y value? Is it positive or is it negative? So do we get a positive or negative result here? Again, you can just plug it in the calculator. You can find it pretty quick. All right, we get a positive here. All right, good. Okay, so we've made up our table here. All right. And now all we have to determine after this point here, so this is step 5. okay, making up this table. Now, step 6 is actually finding the final answer. Now, we have to determine, okay, which one of these intervals are going to be our winner or winners. Well, let's take a good look here at the original inequality. Notice the original inequality said less than or equal to 0. So remember, less than or equal to 0, less than or equal to 0 is equal to any intervals that are negative. Again, bigger than or equal to 0 is positive. All right, you get the general gist. It's not too hard. All right. So because we want to look at the negative intervals, then our winner here, our winner chicken dinner, is going to be this second interval right here. So our final answer is going to be bracket -4, comma 2/3. And that's it. Any questions about that? No? Okay. Again, if you have questions, please let me know. Your interwebs went down. Oh no. Well, you can watch that part of the replay there, Gerda. I will be doing more examples though, so this shouldn't be a problem. Again, replays are here on Twitch for 14 days, so you can actually watch the replay right after I'm done here today, if you wish. So let's go ahead and do another example though. I think maybe another example is in order, nonetheless. All right, let's go ahead and poof that away. Okay. Now that we have the steps in motion, let's do another one here. Yeah, let's do that one. That's okay. Okay. We're gonna switch things up here. Why not? Okay. So we have 5x bigger than 2 minus 3x squared. Okay. So this is our problem right here. Okay. So what should I do first? Get everything on one side. I agree with that. So what should I move? I got I got things on both sides here. So what should it be? What should I move here to make things easier? Now, subtracting the 5x would be okay. Now, you're probably wondering what I'm going to say here next is like subtracting 5x actually would be easy, but it actually will not make the problem easier. Now, you're probably saying, well, wait, hang on a second. Hey, why would I move these two things to the left instead of this to the right? It's because the leading coefficient here of x squared is negative. So it's actually easier to make sure that this coefficient of x squared is positive because it makes it easier. Because it makes it easier to factor. Yes. You want to have it easy time of factoring, so making that number positive is just super simple. Yeah, exactly. So we're just going to add this to both sides and subtract that too. That's right. So putting this all together, we're going to have here on the left-hand side, we're going to have 3x squared plus 5x minus 2 is bigger than 0. See, if you left the 3x squared to be negative, then you would have to actually like multiply or divide by -1. You'd have to flip a sign, and things tend to get pretty messy pretty quickly. All right, so obviously we want to kind of avoid that as much as humanly possible. All right. Now, you can factor this 3x squared plus 5x minus 2. This will actually factor. This factors to x plus 2 and 3x minus 1. Now, if you're not sure how I got that, that's okay. That would be via the AC method there, if you want to use that. That's fine. But the more important part is going to what's coming up next here. So we're going to find our two zeros. So we get x is equal to the third, 1/3, and we also get x is equal to minus 2. Okay. So these are our two zeros here. All right. So that's step 2 right here. No problem. All right. So what is step 3? What should I do next? What is step number 3? What's next? Plug and chug. Take a look at your notes there. What's step 3? Well, well, wait, hang on a second. Yes. Yeah, this is step 3. All right. Ignore my stupidity. I'm not smart. Yeah, we're gonna find the zeros, but we already did. So I'm not smart. It's pretty great. I was absent. My brain is absent from many activities. This part is true. Let's go to step 4. Ah, man. All right, let's go to step 4. So what is step 4? What do we do next? Sorry about that. We're not quite there just yet. Not quite there just yet. For step 4, let's go to step 4 here. What's step 4 here? Chop time. Chop the line. All right. So let's chop up that number line. All right. We're going to see exactly how things work out. So let's get our friends involved and chop up that number line. So again, the number line is going to go like this. Start off at minus infinity. You go up to infinity. Okay. Can we find those study materials anywhere? Study materials for what there, Adam? Are you just talking like the book? So like the book here, this is talking about like polynomial and rational inequalities. The book that we use here is this dude, the Blitzer College Algebra 7th edition book here that has the New York skyline on there and stuff. So that's the book there with the giant chili pepper on it. Yeah. So if you look up things for like polynomial and rational inequalities, you'll be able to find this topic here. Okay, so we're going to split this up here. Let's take a look at our two zeros. We have -2 and 1/3, so we're going to put -2. That comes first, and then 1/3, that comes second. Okay, now here's the question. Are we going to put brackets or parentheses? All right, so we're going to put brackets, you say, around 1/3. All right, now you got to be a little careful here, Jess. That's where we got to be a little extra careful. This is why I put this as a visual representation. So we're going to put parentheses here specifically because we have strictly bigger than 0. That's our original inequality here, strictly bigger than 0. So I'm going to put a parenthesis here on -2 and a parenthesis here. I'll put a parenthesis here and a parenthesis here. Hey, Farhat, thank you so much. And then the infinities always get a uh, get a guy here as well. Okay. So we're going to have our 3 intervals here. Take a look. This is why I have you chop it up, because now you can physically see the 3 intervals that you need. Right, that's fine. But you see physically the 3 intervals that you need, and you don't even have to guess on the brackets or parentheses because you set it up that way beforehand. So it just takes the guesswork out of what intervals you actually have at the end of the day that you need to test over. Because I'm in the mood of doing it the laziest way possible. So, you know, that's just how it rolls. Lazy is not crazy when it works. All right. All right, what is step number 5? Now that we have the 3 intervals that we got here, what's step 5? Crying doesn't help, not in this instance. What is step 5 here? All right, let's take our test points. Let's go ahead and write our interval here. So we're going to put an interval. Okay. So we have -infinity, -2. We have -2 to 1/3. But cry and roll, though. You know, here's my sick extra credit here. Show me, show me a picture of you in your best fetal position cry. Yeah. I'll give you 5 bonus points. Yeah. If you suck your thumb, then I'll give you 10. Oh man. All right. So we're going to go ahead and take the interval here. We're going to take some test points in each interval. Oh my gosh. All right. And then we're going to determine plus or minus here. All right. Let's make this bigger here. Okay. So we'll make this bigger so we can see everything. Okay. And so let's take some test points in each interval. What's a good test point for the first interval? Okay, -3 sounds perfect. How about the next interval from -2 to 1/3? All right, 0. Pretty easy. Yeah, -1 would work too. Both are perfectly fine. And 1/3 to infinity. What would that be? 4? Yeah, 4 works okay. All right, so let's use our calculator again. We're going to go with this function here, okay, our OG function. So we're going to put our test points in each one of those intervals. Let's start off with -3, and you guys tell me what you get. Remember, we don't positive. Perfect. That's correct. Nice. How about 0? This one should be pretty fast. Negative, good. That's right. And how about 4? Will that be positive or negative? All right, positive. That's right. Good. Okay. So we got our plus or minus. We got plus, minus, plus here. Good. Now, let's take a look at what we need here. Let's take a look at our last part here, step 6, which is our answer. What intervals are going to be our winners? Is it going to be the positives or the negative? So we got 2 intervals that are positive, 1 interval that's negative. Which of those intervals are going to be our winners or winners? That's correct. Morning, that's correct. Positive, that's right. The positive intervals will be correct because this is strictly bigger than 0. So because this is bigger than 0, we're looking at positive intervals here in this instance. So our answer here is going to be both those intervals of -infinity to -2, and then we can union that with 1/3, comma, infinity. And that's our final answer for that problem. Any questions about that? No? Okay. Hopefully that's not too bad. All right. Let's go on to the next question then. Now that we've had a good look on polynomial inequalities, let's look at rational inequalities next. Okay, so let's look here at number 10 on the handout, as that's what we're going to do next. All right, so number 10 says, how do we solve for rational inequalities? Okay, let's take a look at a couple of examples, and we're going to go ahead and see exactly how we can attack these problems. Now, the way we're going to attack these problems is going to be really, really similar, um, with a couple of caveats. So we do want to kind of point out what those special things are. Now, let's take a simple problem here first, and then we're just going to kind of use a harder problem after that for our second example. So I'm going to take the one that we have up top here. Okay, so here's our example right here. So x plus 5 over x minus 2 is bigger than 0. Okay, so not too bad. All right, simple enough. Okay, now let's talk about what we actually have to do here first. So let's talk about step 1. Okay, and make sure about this here. Okay. All right. That's correct. Good. Okay. Let's talk about step 1. Step 1 is the same thing once again. Okay. Same thing here. Move everything to one side. move everything to one side. So just basically move everything to one side and put together using the common denominator if necessary. So we're going to look at a problem like that in our second example. But so if you have to put it together into one rational function, then that's essentially what you're doing here for step one, is moving it to the other side and then maybe doing some common denominator stuff, putting it in as a fraction again, and then there you go. You got it. Okay, now let's talk about this next part here, because we have two things actually going on at the same time in a rational function. So let's talk about those two things first and foremost. All right, step two. All right, find the zeros for the numerator function. So remember when we talked about rational functions, we said there's a numerator function and a denominator function. And so we want to find the zeros for the numerator function. All right. Now, there's going to be a big note to go with this here. So note if we have less than or equal to or bigger than or equal to, all right, then use brackets. Okay. Use a bracket next to that zero. Okay. Now, why am I making that distinction? It's because of what will happen next. Find the zeros of for the denominator function, but in this case here, specifically note, regardless of inequality, we must always use parentheses for those zeros. So I just want to point that out here. If we have less than or equal to, bigger than or equal to, okay, we're good to go, okay, and for the numerator. But for the denominator function, okay, yeah, we have to use parentheses regardless. Doesn't matter what you had at the very start, you got to use parentheses. That's just how it has to be. So what does that look like here in this problem? Let's look at this one here. So again, we're just taking a simple approach here, so nothing too complex going on here in this problem. That should be all necessary. So I'm gonna just erase this here and then shrink it back. Okay. No. Thanks. No. Why? Why have you done things to me? All right, there we go. All right. Okay, so let's put our example up here. So step one is already kind of set and ready to go for this problem. So you're pretty good to go for that. That shouldn't be that big of a deal. Okay. So you're set. Now, we're going to find the zeros of the numerator function. Now that's pretty easy since we have x plus 5 is equal to 0. So x equals minus 5. Okay. And step 3 here, we're going to go ahead and find the zeros of the denominator function. Again, very easy. We just said x minus 2 is equal to 0. And so x is equal to 2. Now let's recall here what I said about the notes here for both step 2 and 3. Now take a look at step 2. Okay, we found x is equal to minus 5. That part is definitely true 100%. All right, but are we going to use a bracket or are we going to use a parenthesis for minus 5? So are we going to use a bracket or are we going to use a parenthesis for minus 5? We're going to use a bracket. Take a look at the original inequality. The original inequality says Yeah, so in this case, the original inequality, so we're going to use the parentheses here. So we're going off the original inequality. So if we have less than or equal to or bigger than or equal to, then we use the bracket. But if we're given just strictly bigger than or strictly less than, it works the same as what we had for polynomials, the same deal. Okay, we're going to use parentheses here in this case. So the way we're approaching this for the numerator is no different than how we approach polynomial functions in the last couple of examples. Okay. All right. Now for step 3 here, we're always using parentheses. Doesn't matter. That's just how it always going to be. Okay. Let's go to step number 4 here, and we'll talk about that. All right, step 4 here. Step 4 is to go ahead and once again chop up the number line based on the zeros found in steps 2 and 3. Okay, so once again, we're going to chop up the number line here. The next few steps are pretty much the same as we've talked about before. Step 5, all right, okay, write out your intervals, okay. So chop up the number line found in steps 2 and 3 and find your intervals. All right, take a test point in each interval and use it in the original function to determine plus or minus. And then finally, step 6 here, the same step again. Based on original inequality, determine the intervals that work. Okay, so nothing changes really for these last few steps. They're exactly the same steps that we just talked about before. So in this instance here, so for this instance here, for step number 4, we're going to go ahead and chop up the number line here. So here's our negative infinity. Here's our positive infinity. We have minus 5. And at minus 5, we're going to put parentheses around there. And we have 2. So we're going to put parentheses around there for sure. And then parentheses always go around infinities. That's always true. All right, so we have our 3 intervals here. All right, so our 3 intervals here specifically are going to be negative infinity to minus 5, minus 5 to 2, and 2 to infinity. And there we go. Now we'll just rinse and repeat, and we're going to do the same thing here. We'll take our interval. We'll take our test point. And we'll take plus or minus. Okay, let's write down every interval. Okay, 2 to infinity. All right, let's take some test points here in each of these intervals. Okay, so what's a test point that we can take in the first interval? All right, minus 7 works. Fine by me. Okay, how about the next interval? Minus 6 would also work, absolutely. Negative 5 to 2, it's a good number to choose. 1, okay. 1, just fine by me. How about the last one there? 2 to infinity. 3? Okay. All right, 3 sounds good. Okay. So next, what we're going to do is we're going to go ahead and plug in each of these, or 50, this is true. uh, you're going to plug in -7, 1, and 3, and we're going to find out what the signs are when we plug into our original function right here. So our OG function here. Okay, so let's plug in -7. Is that answer going to be positive or negative? Again, we don't care about the value here. We only care about positive or negative answer. So do we get a positive or negative answer here in this instance? That's correct. The answer is positive. You actually get a negative divided by a negative. You'll actually get positive. Yes. How about 1? Is 1 a positive or a negative? Positive or negative? 1 is positive? Well, let's see. 1 actually will be negative. If you plug in 1, you're going to get 6 over -1. So if you plug in 1 into this function here, you actually get a negative there. So be a little careful about those sign changes. Again, use your calculator to determine what sign you're going to get. Okay, so you can plug in that function in the calculator. You can figure that out on the table. How about with 3? We get a positive or negative answer. Positive is correct. Yes, good. All right, good beans. Okay, so as we can see here, let's take a look. Gerda. Oh, I just saw that. You know what? We'll just do this, okay? We'll just put up the uwu, all right? Everybody likes the uwu. All right. Now, what's going to be our answer here? As you can see from our original inequality, we are looking for positive results, right? Because this says it's bigger than 0. So we're actually going to get 2 intervals that are our winners. It's going to be this first one and this third one. So our final answer here is going to be final answer be negative infinity to -5 union to infinity. All right, let me make that a bit bigger here. There we go. Are the intervals ever inclusive? Yes. The intervals will be inclusive if, for example, let's say this happened to be bigger than or equal to 0. Well, then suddenly the number at -5 will be a bracket that will include -5. That'll be a bracket at -5. It'll be a bracket here at -5. Where we find zeros in the denominator will never be inclusive. That's why we'll always put parentheses there. So it depends, like mostly on it depends on the numerator, really, and where those zeros exist on the numerator is where you can be inclusive in terms of putting a bracket or not. However, if we're talking about the test points, yeah, you cannot choose a 0 for your test point. Okay. Otherwise, you actually effectively do nothing. Okay, let's go ahead and actually, before we do that, are there any questions about that? Any questions at all? No? Okay. All right. So let's take a look at the next question here. And we're going to go over this one here together. This one I'm going to kind of guide you through. So in the test, are we going to need to input the test points we use or not? Unless it asks you for it, probably not. But you need it for determining what the final answer is going to be. So you have to do this chart here, otherwise there's no way you're going to get to the final result there, Jess. So unless it specifically asks you to choose a test point, you probably won't have to do it. But it is still going to be useful. When's the test? I'm going to let you know soon when that test is. I want shortcut. You want a shortcut? Congratulations, you got the shortest of the shortcuts. This is it, right here. All right, let's do this next one here. All right. Okay. So this is our more easy. I kind of wish I could, but I gotta do hard things sometimes. Sometimes I gotta do the hard things, and sometimes we must make hard decisions. Okay. But once hard things are out of the way, then it gets easier after you try it many times. All right. Okay, so what I want to show off here is what happens here at the beginning of the problem really is really the key here. So we want to make this other side 0, so we're going to actually subtract 2 on both sides. So we're going to x over x plus 2 minus 2 is bigger than or equal to 0. Now since we have that, we're going to use the common denominator here in order to put this all together. Now the common denominator here specifically is going to be x plus 2. Okay, that's the only denominator we got. So we're going to multiply x plus 2 on the bottom, x plus 2 on the top. And then we're going to see what we get here for our cleaned up version of this rational function. So we get x minus 2 times x, so that's minus 2x. And then minus 2 times positive 2, that's minus 4. All over x plus 2 is bigger than or equal to 0. Okay? All right, now, the next thing is we're going to combine these like terms. So, of course, we have negative x minus 4 over x plus 2. And we'll make that bigger than or equal to 0. All right, so that sounds fine to me. Okay, so this is our step 1 here, effectively just kind of cleaning things up to make it look just like the first problem that we did here together. And we're just going to repeat the same process as we had from before. So essentially, let's find the two zeros here. This is pretty much step 1. Step 2, finding the zeros. So again, we have minus x minus 4 equals 0 to find our numerator zeros. So we get minus x is equal to 4 if we add 4 to both sides. All right, divide by minus 1. So x equals minus 4. And then in step 3, we go ahead and do x plus 2 equals 0. So x equals minus 2. Okay. We'll go to the next part here, which is step 4. Now we're going to chop up that number line. This will hopefully acknowledge one of the questions that was asked earlier. So here I have negative infinity, positive infinity. Now I have two numbers here, one at -4 and one at -2. Now here's the question. We obviously know we have parentheses here at the infinities. That part's obvious. But let's talk about the other two numbers. Do we have a bracket or a parenthesis at -4? Do we have a bracket or parenthesis at -4? Bracket. That is correct. Very good. And that is because we have a bigger than or equal to inequality here. Nice. Great job, Jess. So I'm going to put a bracket here at -4, and we're going to put a bracket here again, just like so. And then here at -2, since that makes the denominator 0, we're always going to have a parenthesis. Yes! All right, I'm gonna pump up the celebrations. We're gonna put in parentheses right just like so, and let's write out our intervals. Perfect. All right. So our intervals here will be, let's write, I guess we'll do step 5 here, right here. We can write our intervals. Uh, okay, so our interval here is from negative infinity to -4 with the bracket. Bracket -4, comma, -2, parenthesis, parenthesis -2, comma, infinity, parenthesis. Okay, let's take some test points now, okay? So taking some test points here, what's a good test point for this first one? Negative infinity to -4, what's a good test point to try? All right, -5, good. How about -4 to -2? What will that be? All right, -3, perfect. And -2 to infinity. All right, 0. Perfect. Now, we got our test points here. Now, the question is, which one are we going to use? Let's use our OG inequality right here from after we went ahead and simplified it down. So we're going to use this inequality here, or this function here. So if we plug in -5, all right, if we plug in -5, do we get a negative or positive answer? All right, negative is correct. Good. How about -3? How about -3? Positive or negative? All right, positive, good. And how about 0? 0 equals 0? Don't think so. 0 does not get us 0 back in this particular function. Otherwise, you'd be surprised, just like the space. Negative, that's correct. Good. All right, so we have a negative here. Excellent. All right, so let's take a look at our winner or winners in this case. Again, we have bigger than or equal to 0 here. Okay, so if we have bigger than or equal to 0 here, then the winner here is going to be this guy right here, -4, comma, -2. So that's our final answer. Oops. And there we go. We got our final result. Easy peasy lemon squeezy. All right, any questions about that? Oh, darn. Okay. That might take me more time than I thought. Oh well. Okay. Okay, good. Any questions about rational and polynomial inequalities? Okay, so here's what I'm going to do, all right, for the next test. So I do want to talk about this here. We still have a little bit more to go on the handout. That part is true, okay? No question about that. Um, uh, like I said, you want to make the horse an emote. You have the power to do so. I ain't I'll let you do whatever you want. Okay, now we do have a little bit more of a part here of 11 to 15 here. We will finish that up for next time, as I do want to spend a little time just kind of talking about the basic definitions here. It won't take up too much time, but the one thing I will want to say here in regards to that is we are still going to have a test because I certainly know we're going to finish this up for next class. So the test here, the test will be due next Thursday. Okay, so next Thursday, which is going to be the 15th. Okay, so the 15th here. So next Thursday, the 15th, is when the test will be due. I'll put up a little announcement there, send out a little email. That is when the test will be due. So essentially, you'll have until then to go ahead and finish that up. All right, so ah, I know. Okay. The homework will also be due on that day. Yes. So I'm going to show this off here on screen. Like I said, I'm in the mood of just giving you transparency. So I just want to be like, okay, let me give you transparency here. Let's go to assignments. I want to do that. Sorry about that last part. Manage the assignments there. Uh, yeah. Okay. All right, here we go. Yeah, as far as I'm aware of, yes. So this one here has much fewer than the others. So, all right, so let me go ahead and edit this so you guys can see that I was not joking. You know, I wasn't doing bad things. Okay. Um, don't I have to change the due date for that? How did I do that again? Uh, hmm, what was that again? Yeah. Oh, yeah, right. Yeah, do that stuff. Okay, let me quick edit this. All right, so this you can start on today if you like. This will be due again on the 15th there at 11:59. So that is now saved and ready to go. Let me make sure I got that practice test. So once again here, there's a grade book that you can check your grades on. So if you see the grade book at the top, you should have that same option there for you, or it should say grades. I still have to up now. To be honest, Chase, I still have to update the grades there, so that's something that I have to do. Okay. All right. So now you have the practice test and the real test. Okay. And I just got to reset the homework here. Eventually, I'm going to figure it out one of these days. I think it's this. Okay, it is. Good. Where's Unit 3? Here it is. So we're going to make that the 15th. Okay, so those are all open till the 15th. So looks like it set itself without too much trouble. All right, good. Okay. Just making sure. How many tries for the test? Oh, yeah, great question. Yeah, thanks for reminding me about that. I could have sworn I set that, but let's check one more time. Okay, so again, let's check one more time for the test there. So, no, yes. Okay, yeah, you get 4 hours to finish. Uh, create extension. I could select some things. You get some other things. Yeah, you get two attempts for the test. So 2 tries. Yeah, I thought I set this okay. You get a full retake here. Um, and then you get the best score of that for those tries. Does that work? Cool. Yeah, so the better of the two scores are the ones that you get, and you get two takes, two retake. You get one retake, so that way, if you don't do so hot the first go round, then it's like okay, you try the second go round, you'll do better. Yeah, I always give a retake, so that's fine. I know for computer-based tests it's kind of a pain, so one and done doesn't really make much sense. Now, one thing I do want to point out here, as well as for what we're going to be doing Thursday, we're going to finish up, of course, this last section here, section 3.7, like you saw in the handout, but we're also going to do the same thing we kind of did last time. We're going to cover some of the questions there from the practice test. Okay? All right? Procrastination Station's calling you. It's chugga chugga choo choo. All right. All right. So, yeah, we're going to be reviewing here using the practice test number 2, just like we talked about last time. I'm not going to go over all the questions like I did last time for the first practice test, but I will go over a selection of them with the remaining time that we do have after we finish up the last section. So if you see any questions in the practice test between today and Thursday, please let me know during next class, and I'll be happy to take those questions first so we can go through them carefully and get those done. I can't go through 40 questions again. That was quite a bit. That took me like 3.5 hours. That was a long one. I know, but I understand. It took me a long time to get that last one there. That was a tough go. Like I said, I wish I could go over every problem, but realistically, it'll take me too long. But like I said, let's focus on the questions that you guys have specific questions on. The ones that are the hardest for you. You have a chance to look through the whole practice test and see which ones are the toughest and which ones you'd like me to do specifically, so that way we can get those out of the way if they appear on the exam. Okay? So I want to give everybody a fair shot. All right? All right. No problem. Any other questions? No? Okay. All right. If there are no more questions here, this is where we're going to end off here for today. We're going to come back on Thursday. We are going to do exactly as I say here. We're going to finish off Chapter 3. We'll talk about review for here for the exam. Again, get that homework done by next Thursday. That's very important. Let's get her done. All right. So, all right. Thank you very much, everybody. Thank you. Thank you for coming out here today. I really appreciate all of your time and effort for coming out to the stream and wanting to go over new material with me here today. It makes it all worth it in the end. Um, yeah, I will see you in on a couple days. Okay, see you on Thursday. All right. Do I know when you'll be returning to the classroom? It will not be until at minimum next summer. They have already called the semester for the spring, so at minimum next summer. Yeah, there would be no in-person classes until this next summer at least. I'm just going to tell you that right now. Unfortunately, that's the reality of the situation as it stands. I know. I know it's very disappointing, but the college has to be, you have to understand the college has tried to take every precaution. I usually get a lot of I usually get emails about a person being on campus who has been COVID positive. They have to, scrub down and disinfect and do the whole 9 yards. And with thousands of students kind of roaming about, it would be literally impossible to keep it contained. It could cause another spreading event. Yeah, you have to unfortunately, you have to take precautions with a disease that unfortunately has such severe cases and could cause fatalities. So they do take it very seriously, and they had made a decision actually weeks ago. They have been having internal discussions for about a month or two. Um, so even in the summer, they had discussions whether or not they were going to do spring classes. I'm glad. Look, this was the alternative. I know. One thing I would understand is that I wish I was face to face with you. I wish we were sitting in a classroom, sitting back and chilling. But your health and safety has to come first. 100% over my needs and wishes and your needs and wishes. unfortunately, we have to look at for the community at large. So, yeah, just do understand that even if they don't have summer classes, in person, they probably still do the online classes thing now that we've more integrated with the online things. But I'm not going to be surprised if it's until next fall when maybe we get back into the swing of things for in-person classes. So, um, I only say maybe because again, we don't know what will happen between now and then. But yeah, at least till summer, um, unfortunately, there won't be a way to go back to campus at this time. Of course, I'll keep you up to date if there's any changes in regards to that, but that's the most information that I've been given so far. All right. Okay, everybody. Uh, Again, thank you very much. I will see you all on Thursday. All right. Have a great day, everybody, and we'll see you later. All right. Bye.